Hey, welcome to 49cc Scoot. My name's Brent. I installed the Malossi RC1 94cc engine in my scooter months ago, and I didn't change anything in the CVT from initial assembly and only adjusted the float height and idle speed and mixture settings on the carburetor. Otherwise, the carburetor was left just as it came from Malossi, and it ran surprisingly well. I don't think I've ever used a totally new engine configuration and had it work so well from the start, but I still wanted to go through a tuning process to see if I could improve performance by dialing in the jetting and slider weight or other CVT mods if needed. Unfortunately, I've had some issues along the way that have held up any fine-tuning for quite a while now, so this video is going to be all about my experiences trying to sort out those problems and trying to get the Scoot to a point that I could finally start tuning. If you're looking for a tuning video for the RC1, make sure you subscribe so you can check out my future videos, but I would suggest watching this one as well. I think it will show you the importance of getting everything right before you try to tune, and I even learned something along the way that I think will be helpful to a lot of us when setting up fuel systems. Before I attempted any tuning, I bought a Dragy to try and improve my usual process. If you've never heard of a Dragy, it's this small device that connects to its own app for a smartphone via Bluetooth and tracks performance. The Dragy can do all sorts of acceleration related tests like eighth mile or quarter mile, 0 to 60, and it has tons of custom configuration options so you can set it up to suit whatever your needs are. It contains a GPS receiver that updates much more quickly than a standard phone can, so it can greatly improve accuracy versus GPS apps without their own receivers. I've got a video of me trying out free GPS apps on my scooters if those interest you, and they can be fun to use and get a ballpark idea of performance, but they aren't a great tool for tracking changes. I've tracked performance for years using a calibrated speedometer and a helmet cam. Filming runs where I'm able to see the speedometer lets me time runs and has proven to be consistent and helped me dial in quite a few setups. The problem with timing by video is that it is very time consuming and probably not accurate to compare with more customary methods like going to a track. After watching multiple videos showing the Dragy tested versus track timing with great success and seeing it used by racers like many of the street outlaws, I decided to give it a try. And by the way, this is not a commercial. I paid the normal price for my Dragy out of my own pocket and no one asked me to check it out. I will put a link in the description if you'd like to purchase your own, but I'm sharing my experience so you know exactly what I'm doing, and because I wound up really liking the Dragy and wanted to share that for anyone else interested in a similar device. I had to do a little bit of testing before I would feel comfortable using the Dragy to suit my needs. Since I knew that my video timings have provided consistent results, I did some acceleration runs with the Dragy and also timed them by video to compare 0 to 30, 40, 50, and 60 miles per hour. And here's what I ended up with. Dragy and video times differed by anywhere from next to no difference to around a half a second of difference. In most cases, the video timing was about 3 to 4 tenths slower than the Dragy timing. That is what I would have expected, because I start my timing when the throttle opens and the Dragy doesn't start until the bike begins to move. I've also always thought that my timing method must incorporate some amount of lag in the time that it takes for the speedometer to display what it's sensing, while something like the Dragy is much more direct. Most importantly for me, I could identify the quicker or slower runs with both sets of results. Each method pointed to the same runs as being good or bad by similar amounts for the most part. It appeared to me that the Dragy should work as my new timing method and should also provide more accurate results for comparison with my own or other people's time. Once I was happy with my new timing tool, I wanted to start doing some test runs with main jets and compare the information that I got with the information I've already collected with the 150 main jet. So I started out with a 155 main jet. Then I tried a 160 main jet. I didn't need any timing method to tell me that there was a problem at that point. It seemed like the float bowl was either running low or dry during acceleration runs with a larger jet. Once it sat for a few seconds, I believe the bowl would refill and then it could go again for a little bit. The engine felt strong just before it started to totally run out of fuel, which made me think that it may like a smaller jet. Since it was fine with the 150 and 155, I tried a 145 main jet as well before worrying about whether I needed to work on the fueling issue. Here are the results from the 145 to 160 jets. It seemed that the Scoot liked the smaller jets the best, but I didn't trust these results very much because of potential fuel supply problems. I removed the carb and checked the current float arm height. In the few times that I've done adjustments, I've gone from overflowing fuel to running the bowl dry, so I assumed that I would need to be much more precise than I have been and actually take measurements instead of just bending the arms a little bit at a time. My calipers won't reach from the flat outer base section of the carburetor to the tabs for the floats, which would be the common way to measure float height, so I had to improvise a little bit. I measured from the top of the rounded area here to the float arms. It's not exactly ideal, but I think it's good enough to work. I found that my floats were set unevenly from side to side, with one measuring about 21 millimeters and the other about 21.5. I set the float arms to parallel with the carb body and measured that setting to be about 19.5 millimeters. I didn't measure before changing the float height the very first time, but generally parallel is the stock specified setting, so at least I'd have that as a reference. I had fuel overflowing when I first installed the engine and carb with a stock setting, so I wanted to set it somewhere between where it just was with running out of fuel at 21 plus millimeters and where it previously leaked at 19.5 millimeters, I would assume. So I set the float arms to 20.5 millimeters. The largest main jet that I had at the time was a 165. I didn't anticipate needing a jet that big, but a bigger jet should consume more fuel and drain the bowl more quickly, so I wanted to use it for testing. I did 4 back-to-back 0 to 60 runs and then ran it up to about 75 miles per hour without any problems. So it looked like my fuel issues were fixed and I could go back to main jet tubing. I reinstalled the 160 jet and went to do more test runs. They went well at first, but on the third try the bowl ran dry again. I tried again and the same thing happened. Now this makes no sense to me. I used a larger jet and had no trouble, and then swapped to a smaller jet and then the bowl runs dry. I've learned in the past that mixing and matching jets or using generic jets is a bad idea, so all of these are genuine Del Orto jets. I don't have any way to measure every size precisely, but I didn't expect orifice size variance to be the problem. Even as is, the carb was still spitting fuel out of the vent hose at times. It was fine sitting upright or leaned over on the stand, so I assume that it was from fuel sloshing around, but I know that it leaked in the past with only a small change in float height, so I didn't see increasing height as a good option. I did a few tests while checking float height earlier to see how much difference the fuel level made on the volume of fuel in the bowl. These were very quick tests, but it looked like every millimeter of fuel level was roughly 3.3 cc's of additional fuel. That didn't seem like enough of a change to me to make it possible to raise the float height enough to never worry about running the bowl dry without having it overflow regularly. Something else had to be happening, and fuel flow was the most obvious potential issue to me, so I gave the fuel system a quick look to make sure nothing was obviously wrong. My fuel system is very basic. I've got a 2.5 gallon spun aluminum gas tank mounted pretty high on the scooter. It has a 1/4 inch straight hose barb in the bottom attached to a 1/4 inch Tygon fuel hose. That runs to a 1/4 inch manual shutoff valve, then to more 1/4 inch hose, and a 1/4 inch mesh or screen style fuel filter. Finally, I use 3/16 of an inch Tygon hose to attach the filter to the carburetor because the nipple on the carb is too small for 1/4 inch. I tried 1/4 inch with a cable tie to secure it when the engine was first installed, but the larger hose just would not reliably seal, so I switched to 3/16. I let fuel flow into a container for 30 seconds and measured the amount of fuel transferred, and then repeated the test a few times to reduce potential errors. The most flow that I measured in 30 seconds was 150 milliliters, but on some tries it flowed much less, as little as 50 milliliters on one test. I tried taking the gas cap off, thinking that perhaps I had a venting problem, but that didn't change anything. I started putting a measured amount of fuel into the container before flow test and submerging the end of the hose in that, and then found that I could get 100 to 150 milliliters every time. My friend Ryan, who you've seen ride with me at times with his Zuma, has an RC1 with a 34mm carb and a much larger main jet, and he tested his fuel flow at 175 milliliters in 30 seconds and hasn't reported any fuel starvation issues. My numbers sounded like they should be good enough to me, as long as it would consistently flow that much. I put the hose back on the carb, but I began wondering if air pockets that I sometimes see in fuel lines or the filter could have some effect. Maybe if I worked out the air bubbles by pinching and releasing the fuel hose repeatedly to help fill them more completely, it would solve my problem. I took an 11-mile ride and ran the scooter up over 70 miles per hour a couple of times without any issue. Maybe it was really that simple. I went back to carb tuning the next day, and it ran the bowl dry on the very first pass. I tried making sure the air was out of the fuel lines. I tried taking off the gas cap. Same thing. For lack of any better plan at the time, I set the float height to 19 millimeters, which I believe should be higher than it was out of the box when it leaked, but it didn't leak this time. I made a couple of test runs with it, and it didn't drain the bowl, but it seemed like it was too rich wide open throttle now. With the carburetor mounted at an angle, float height may have to be just right to avoid fuel starvation or overflowing in rich conditions. Because it seems so finicky to me, I decided that getting a clear float bowl may be the easiest way to reduce aggravation while trying to sort this out. It took a little while to get the clear float bowl, and I got wrapped up in other things, like fitting the Aerox front wheel. I could ride the Scoot without issue. Most of the time I'm riding at low speeds with small bursts of throttle, and it ran fine that way, and the RC1 has never felt lacking in power or torque, so I just didn't worry about trying to tune it for a while. I rode to a friend's house around the end of July, and the scooter was sputtering more than usual at low throttle positions. It's normal for it to sputter at low throttle, and I actually like it to sputter a little bit at low throttle when it's well out of the power band, but not as much as it was. I initially assumed that it was hot and humid weather coupled with the large 160 main jet, but when I left my friend's house, I couldn't even get it up to speed. Sputtered and bogged at any throttle position under load. It idled alright, and I could rev it when the clutch wasn't engaged, so I tried stopping and seeing if I could take off quickly and get it to clear out. Sometimes when a spark plug is fouling, the engine will struggle until RPM is up, and then it can build up a little bit of heat and clear itself out. Unfortunately, I couldn't get it to go no matter what I tried, so I pulled over again. I always carry a spark plug and tools to change it because this is a pretty common event for two-strokes, especially the more high-strung race-like setups. Once the new plug was in, it ran much better. My friend told me about seeing a small group riding what he said had to be tuned scooters in town, so I rode to town hoping to find out just how tuned they were. No luck. I hear of scooters around here on occasion or see a stock scooter around, but it's been at least a decade since I've just randomly encountered another two-stroke with much work done riding locally. The Melosi clear bowl for the VHST carb came in, so I opened it up to check it out. It came with a new O-ring for the bowl and its own main jet holder with an O-ring for that as well. The clear bowl uses a little bit different jet holder with a larger flange to support the plastic bowl better. I wanted to install the O-ring to prep the bowl, so I applied a very thin coating of grease to it. Then I attempted to put it into the groove for the bowl, but it seemed to be too long to fit. It's possible that I stretched the O-ring a little bit when applying grease, though I do know to be fairly gentle with O-rings, but I could not get it to sit properly. I tried using freeze spray, hoping to shrink the O-ring and/or stiffen it enough to keep it in place. That didn't work, so I tried putting it in the fridge for a few hours, and that didn't work either. I tried putting the O-ring in hot water for a while to no avail. I even tried putting it in boiling water. Nothing worked. I finally gave up and decided to cut a section of the O-ring out so it would go all the way around the bowl and the ends would touch without slack. I don't like to do this if I don't have to, because it can create sealing problems, but the bowl is not pressurized or under any great amount of stress, so it should work. I placed the joint on the inlet side of the carburetor in the center, so that way it shouldn't have as much fuel in contact with it because of the angle that the carburetor sits at when it's mounted to the engine. I used a dab of Permatex Ultra Gray where the ends meet up to help it seal, and I was later told that super glue can be a great choice for this. I put the bowl in place and installed a 170 main jet in the new jet holder. I picked up more jets while I was waiting for the clear bowl, so I used the larger jet thinking that it should still run well enough based on what I've seen so far and would stress the fuel supply even more. I installed the carb, but before I hooked up the fuel line, I swapped my fuel filter out for a Melosi mesh filter that I picked up from ScooterTuning.Ca. By the way, if you need parts for your scooter project, be sure to take a look at ScooterTuning.Ca. They ship fast and affordable and carry a whole lot of fun stuff for scoots. They also support this channel with discounts on parts to help me keep my projects going, so please support them. I did a couple of 30-second flow tests with a new fuel filter to see if anything changed, but the results were basically the same as they were with the last filter. I hooked the fuel line up and let the bowl fill. I was expecting the fuel level to be low or to see it fill slowly, but everything looked fine to me, so I set up a camera to watch the bowl and headed out for a road test. I started with some pulls from a roll. Here I held the throttle wide open for about 15 seconds and fuel level didn't appear to change much, and that's the experience that I had doing all rolling tests. Then I tried accelerating from a stop. This was my first attempt, and you can watch the bowl draining pretty quickly. I stopped and got off to look at the bowl, but it was already refilled by the time I could see it. I pulled up just past the curve ahead and tried again. This time it went over 30 seconds at full throttle with no sign of quitting. At this point, fuel shortages are seeming random to me. It's been like this throughout the process, but even with watching the bowl, I can see that sometimes it's draining and sometimes it's maintaining, and I can't find any difference from one test to the next to tell me what may be happening. I could see that the floats were not stuck when it ran out of fuel. They were definitely down to allow fuel in. If the float was letting fuel in and the bowl wasn't refilling, or at least not refilling quickly enough for the demand, then it would pretty much have to be a fuel flow problem. So I inspected the fuel system for any debris that may be causing random blockages or any flaws, but I didn't find anything. Then I went back to fuel flow testing, beginning with eliminating the fuel filter. I used the same 1/4-inch hoses from the tank to the 1/4-inch shutoff valve, and then attached 3/16 of an inch hose after the shutoff valve, since the carburetor needs the smaller hose for its connection. I was surprised to see that gas came out much more quickly, and it transferred 425 milliliters in 30 seconds. That's nearly 3 times as much as some of my previous best results. It certainly looked like fuel filters were costing me a whole lot of flow, but it just didn't make sense to me. I couldn't see how a simple screen type filter could possibly be that big of a restriction. I added the fuel filter to the end of the setup that I had just tested. So it went from 1/4 inch all the way up to the shutoff valve, 3/16 hose after the valve, and then a 1/4 inch or equivalent mesh filter. It still moved 375 millimeters of flow in 30 seconds. Now it's getting confusing again. How can it be that it flows 150 to maybe 175 milliliters on its best day before with a filter, 425 milliliters without a filter, and now it's still at 375 milliliters with a filter in place? My best guess was that perhaps the hose on the outlet of the filter really mattered. I did another test adding a length of 3/16 of an inch hose to the end of the fuel filter instead of leaving it open. It flows even more, 450 milliliters in 30 seconds. There has to be something going on related to the hoses before and after the filter. I wanted to try going back to 1/4 inch hose before the filter and 3/16 after, just as it was set up on the scooter before, but the filter broke when I tried to pull the small hose off of it. I didn't have another filter like it, but I did have a smaller version of the Melosi filter labeled as 6 millimeters that matched up well to a 3/16 of an inch hose. The filter that I was using was labeled as 8 millimeters, but matched up very well to 1/4 inch stuff. I tried using 1/4 inch hose before the smaller filter, and then 3/16 hose after. That flowed 375 milliliters, so I was definitely going in the wrong direction. I switched over to 3/16 hose before and after the fuel filter, and flow went back up to 450 milliliters. It seems like there needs to be some sort of back pressure, or maybe it should be called head pressure for plumbing, to get the most flow through the fuel filter. I wanted to find out what would happen with a 1/4 inch filter using 1/4 inch and 3/16 inch hose before it, but I didn't have any more scooter filters around. Luckily, I did have a 1/4 inch paper filter on hand with some lawnmower spares, so I gave that a try. I started with 1/4 inch pre-filter and 3/16 post, and it still flowed 450 milliliters. Okay, maybe I was wrong and there's something else going on. I switched over to 3/16 of an inch before and after the filter, and it flowed the same 450 milliliters. While the results are not exactly clear and straightforward, what I gather from testing is that it's best to use the same size hose in and out of these fuel filters. The mesh filters appear to be significantly affected by differences in the hose diameters or lack of an outlet connection, while it didn't seem to matter either way with the paper filter. I also didn't see a change by switching hose size on one side or the other of the shutoff valve. A lot more testing would be needed to come up with a conclusive result, but the main takeaway for me is that I will not be mixing and matching hose sizes around fuel filters anymore. I thought that I was providing as much flow as I could by having the 1/4 inch hose all the way up to the filter before it had to switch to the smaller hose, but it looks like I was inadvertently causing myself a bunch of headaches. Flow numbers aren't even required to see how much difference there is from where I started to the way that fuel moves now. Okay, perfect. That's sorted, so I can finally get to selecting a main jet with some tuning runs. I left the 170 main jet and the clear bowl on the carb for my first test. I mean, I might as well stress test the newfound fuel flow with a large jet. The engine sputtered and exhaust gas temps were low, so it was clearly too much fuel. I moved down to a 165 main jet and somehow it got worse, still sputtering and more than half a second slower than it was with a 170. The results so far reminded me a little bit of a fouled spark plug, but the first one lasted over 300 miles, and this one's got only 50 miles or so on it. My next guess was that maybe the float height still wasn't quite right. I set the float height to 21 millimeters to lower the fuel level, but when I turned on the fuel shutoff valve, the bowl didn't fill at all. I took the carb off again and ended up finding that the floats can bind in the clear float bowl. The rods that the floats ride on are larger in diameter in the Melosi bowl than they are in the original Del Orto bowl, and there was a little less clearance around the floats. If I tightened the jet holder, the floats would bind and couldn't move. I could loosen the bolt a little and then they would move, but then it was loose enough that the bowl would leak. I didn't have that problem when the bowl was first installed, so I wasn't sure if it warped or otherwise deformed during its limited use or what exactly changed. I switched back to the original float bowl and also moved the float height back to 19.5 millimeters, still using the 165 main jet, thinking that maybe the floats were binding for a while and throwing off all my results. That didn't work at all. Once again, I managed to make it even worse. I was stuck on the idea that the float height absolutely had to be wrong, so I put the clear float bowl back on, thinking it was good enough to do some bench tests. With the float arms set at 19.5 millimeters, fuel was pretty much all the way to the top of the bowl. I switched to 21 millimeters and the fuel height stayed the same. Then I moved to 24 millimeters and the fuel height still didn't change. The only difference I've noticed is that now it takes a really long time to fill the bowl. You can see I'm actually running this at 4 times speed, and it looks fairly similar to what you saw with the last setting at 21 millimeters. So apparently it must be restricting the flow coming in through the needle and seat. Okay, maybe even with me barely tightening the jet holder for bench testing, the float's still stick enough that it throws off the float height. I really wasn't sure, but I thought it would be best to go back to the original bowl. The only problem is, I still wanted to see where the fuel level was with float height changes. I was done with the clear float bowl at this point because it was too much of an unknown and clearly capable of causing problems, so I had to come up with another way to check fuel level. One common method is to attach a clear hose to a float bowl drain and route the hose upward. With the drain open, fuel will flow into the hose and sit at the same level of fuel in the bowl. That sounds great, but this bowl has no drain barb, and I didn't want to drill and tap it for one. Luckily, I did have the jet holder from the clear bowl that I could modify. The jet holder had a couple of areas that needed to be machined down because it wouldn't even fit into the aluminum bowl otherwise. Then I drilled through the center so I could push in a piece of plastic hose barb with a very snug fit. I added a little bit of super glue for insurance. This isn't exactly something that I'd trust for riding, but it should work for the bench tests. I left the height at 24 millimeters and the fuel still came up near the top of the bowl. I marked the level and then switched over to 19 millimeter float height and rechecked. It may look a little off due to camera angle, but the height came up to the same mark again. This is not how float height is supposed to work at all, so I needed to find out what was causing my inability to change the fuel level. I connected a vacuum pump that I typically use for bleeding brakes to the fuel inlet of the carb. Then I applied vacuum and watched the gauge on the pump to see if it lost vacuum. This checks the sealing ability of the float needle and seat. If they don't seal, there will be a vacuum leak and the gauge will move. If they do seal, the gauge reading should remain the same. I also tried spraying a little bit of soapy water around the needle and seat while vacuum was applied to make sure I saw no bubbles that may also indicate a leak, and it passed all tests. Each one of the floats has a weight noted on it along with a part number. Both of mine say they were supposed to be 3.6 grams. I weighed the floats and each of them was 3.8 grams. I double and triple checked the calibration of the scale with its reference weight, and I tried measuring other things of similar known weight to make sure that it wasn't a scale error. 0.2 grams heavier doesn't sound like a lot, but without finding anything else obviously wrong, I had to assume that the heavy floats were the reason that I couldn't change my fuel level, so I ordered a new pair of 3.6 gram floats. By the way, there are 3 versions of floats for this carburetor in different weights, so take note of that if you ever have to replace floats. I should also mention that I'm sure someone will wonder why the floats would be heavier. It's possible that the floats could have a pinhole and take on fuel that way, and you may even be able to see or hear fuel sloshing around inside if that's the case. Some materials will absorb fuel over time. My understanding is that plastic floats may be more susceptible to absorbing ethanol fuels, possibly depending on the amount of ethanol content and the makeup of the plastic, and I believe that this is the case for me. I use 10% ethanol premium pump gas all of the time. I'm not against the idea of ethanol-free fuel, but it's not really practical for me. There aren't a lot of stations that carry it, and the ones that do don't always offer premium, which I like to use because of the high compression and more aggressive timing of tuned engines. Even though I do fill up from a gas can regularly, I prefer to use a fuel that I can get while I'm out riding if needed, and it's a 4-mile trip to the nearest station to get 93 octane 10% ethanol, while it's over 50 miles to get ethanol free with similar octane rating. If I repeatedly have float problems, I may consider it, but for now I'm sticking with what I've been using. When the new floats came in, I weighed them, and they came out to about 3.7 grams each. I didn't expect that, but at least they were lighter than what I had. I set the carb up level in my vise with a float height set to 19.5 millimeters and marked the fuel level on the side of the bowl. Then I set the float height to 21 and 23 millimeters and marked those heights. At least I can change the float height now, but I also wanted to take another look at where the fuel level is when mounted on the scooter. I started by using a digital angle gauge to measure the angle of the top of the carb while installed, and that was 27 to 28 degrees. This will change with weight on the scooter and as the suspension works, but at least it's a rough idea. I then used a spare intake to mount the carburetor in the vise at a similar angle. Moving the drain hose across the bowl shows the fuel level in any position, so I marked that on the bowl. I also marked where the main jet would be so I could get an idea of how much fuel would be sitting above the jet. Remember that this is at a 23 millimeter float height setting, which should be a lower fuel level than most settings that I've tried. Initially, I was concerned about how much fuel would be above the top of the main jet, but I then realized that fuel is picked up from the bottom of the carburetor, so it would have to be very low for fuel starvation. I set the float height to 20 millimeters and went for a test run. Still way rich. So much for an easy fix. I tried setting the float height as low as 23 millimeters and it was still breaking up badly. I did have a 165 main jet in it at this point, so I thought maybe now the jet is just too big, especially since it was breaking up starting around half throttle and then getting worse approaching full throttle, which would be similar to the most effective range of the main jet. I set the float height back to 21 millimeters, sort of a midway point from some recent runs, and installed a 155 main jet. I spun the rear tire when trying to get moving in the driveway, which surprised me a little because I've had to wait for it to clear out before it wants to move lately. That seemed to be a good sign. I didn't really get anywhere with a high throttle sputtering though. I swapped to a 145 main jet, and it started to feel very snappy at part throttle. I think the Scoot has been acting up for so long that I forgot how aggressive this engine is supposed to be. Sadly, it still wouldn't run right under heavy throttle. I continued down to a 135 main jet, and it ran very crisp and clean down low, but still broke up badly with heavy throttle, and this time the EGT went over 1300 in under an eighth mile. I tried setting the float height to 20 millimeters to raise the fuel level a little bit, thinking that maybe I was wrong and I was experiencing some symptom of fuel starvation rather than a rich condition, and that could be why the EGT was high. It didn't make a lot of sense, but I've had so many float issues and struggled to get it to clear out, so the extra test wouldn't hurt. I couldn't do a full run on flat ground because for some reason a dump truck decided to park in the middle of the road for a while, but it was still obvious that it wasn't working. With the high exhaust temperature, I didn't see smaller main jets as a wise choice. Using a jet that seemed lean, and still having a sputter with heavy throttle made me think that I had to have something wrong with either the carburetor or the engine, or the ignition was somehow failing under heavy load. I used an adjustable gap tester to see if I had a strong spark, and it would jump a gap greater than 1/2 inch repeatedly, so it looked like the ignition was delivering enough power. Ignition timing can also cause problems, but the symptoms just didn't remind me enough of timing issues to make me check them right away. I took a look at the reads with the carb out, and from what I could see, they looked fine. I decided to clean the carburetor and air filter and see if anything changed. I used a 50-50 mix of Pine Sol Original and water in the ultrasonic cleaner, as I've seen suggested online for carb cleaning, but I've never tried it before. I don't think I'll be using Pine Sol for this much more. It did get the brass parts very clean, but the aluminum was darker and the steel parts were beginning to corrode. Initially, I thought that maybe I shouldn't mix metals during cleaning, but others have showed carburetors tossed in with no disassembly and coming out clean. I cleaned the air filter with K&N filter cleaner because it's the only filter cleaner that I had around. Then I rinsed it with water and hung it out to dry in front of a fan. Once dry, I oiled it and reinstalled everything. I used a 145 main jet to avoid high EGTs and tried again, but nothing changed. I had a 28mm Del Orto PHBH around. It seems a lot like the 28mm VHST that I've been using, but it's a round slide instead of the sort of hybrid flat round slide that the VHST is. It also has a more traditional float setup rather than the independent floats. I installed a 150 main jet and left everything else the way it was when I last used it on a mild 96cc. Most of the install was very simple since both carbs were the same size on the outlet side and similar height and width. The adapter on my PHBH was the right size to work with a Melosi pod filter minus its rubber bell mouth like adapter. The only trouble that I had was with the throttle cable. The PHBH needed more free cable than I could get out of the one that I was using. I had a new cable around labeled for a GY6, presumably with a PWK swap, that also needed more exposed cable. I modified it so I could leave my working cable for the VHST alone. This is yet another of my least favorite scooter jobs. I carefully cut through the sheathing with a small cutoff wheel to separate the length that I wanted to remove. Then I cut a little of the metal inner protective part lengthwise. I didn't even cut all the way through, but removed most of the material along a line. All of these cuts have to be made very carefully to avoid damaging the cable. Even a small nick that seems harmless can lead to fraying and ruin the cable or cause it to get stuck. The metal liner is basically coiled around a plastic liner, so I use cutters to remove small bits at a time. For me, this is easier than trying to cut all the way through and risking cutting the cable. I continued doing that until I reached the end of the sheathing and the ferrule, and then cut the ferrule and basically peeled it off before finishing the rest of the metal protective covering below it. The plastic inner liner comes off pretty easily with a razor knife, and then you just need to make sure that you haven't left any sharp edges at the end of the sheathing that could damage the cable. You could cut the end off of the throttle cable, cut the sheathing and slide it off, install a new ferrule on the end of the sheathing, and then install a new barrel on the end of the cable. That's probably the most technically correct way to do the job, but I can tell you from experience that you have to be careful doing this because sometimes solder doesn't stick to the cable as well as it should, and the barrel can come off, leaving you without an operational throttle. My first attempt with a PHBH was way too rich. I switched the 150 main jet out for a 135 and it was much better, but still rich in most throttle positions and still sputtering on the top end. The needle clip was in the richest position, so I moved it up 2 spots to lean it out a bit. That improved low throttle riding, but it continued to sputter above half throttle. I tried 130 and 120 main jets, and it never quit breaking up at high throttle openings. I don't think it's very likely that 2 carburetors would end up acting the exact same way, so I decided to do some engine checks. Even though it was lifting the front wheel at in-town speeds and felt strong at lower throttle, I checked cranking compression. Unfortunately, I never checked when the engine was first assembled for a reference, but I got 155 to 160 psi on one gauge and 135 to 140 on another. Both should at least be enough that the engine isn't struggling due to loss of compression. I decided to remove the engine because I have had liquid-cooled setups with sealing issues that acted up in somewhat similar ways. It didn't seem like the most likely cause, but I had 469 miles on the engine, so I was also a bit curious to see how things were wearing. When I drained the coolant, it came out dark with tiny black particles in it, which made me even more suspicious of sealing issues, though it could be leftover from past combos. I thought that I'd be able to remove the rear brake caliper, and then the wheel, rotor, and spacer could remain on the engine, but the caliper just didn't want to fit out of the wheel. I was told by some that this is normal, but Pew Pew from the 49cc Scoot forum says that pushing the pads against the rotor to push the pistons into the caliper may allow the caliper to be removed. I haven't tried that yet, but I'll definitely see if that works next time around. I cleaned the engine a bit and then removed the exhaust flange so I could install a block-off plate for a pressure test. While I was there, I looked through the exhaust port and the piston and ring looked good, and the ring didn't appear to be seized in the groove. I did a pressurized leak test to make sure that I didn't have a bad leak causing all these strange things, but it passed the test with flying colors. I removed the intake to look at the reeds, and they looked brand new. They still sat snug against the reed block, and all of the edges were very smooth. I set up a dial indicator and checked the MVT ignition to make sure that nothing had changed since it was installed. It was still right at 0.35 millimeters before top dead center as originally set, so if there are any timing issues, it would have to be in the CDI. I pulled the cylinder head off and looked over the top of the cylinder and the inner head for signs of leaks or anything unusual. There were a couple of spots where I wasn't sure if coolant or combustion gases could be escaping past an O-ring. Otherwise, it looked good and the O-ring markings were pretty clearly defined. I removed the cylinder and then looked the piston over. The ring moved freely and the piston appeared to be in good condition overall. The cylinder looked very good. There was some light scuffing, but not much, and I couldn't catch a fingernail on anything. I'm not sure that it shows well here, but I could still clearly see the cross-hatching on the cylinder walls. I cleaned everything and then measured the piston ring end gap, which was 0.010 of an inch. The initial setting was 6 thou. I do have a brand new ring here, but I'm not even concerned about this one with that gap. With everything clean and no oil, I thought that the piston ring may be a little bit more snug in the groove than it should be, so I used feeler gauges first to measure side clearance. I could fit a 1.5 thousandth feeler gauge in there, but it was a snug fit. I also tried using stacked feeler gauges to measure the ring groove and a mic to measure the ring thickness. The ring groove came out to 33 thousandths of an inch, and the ring was a little over 31 thousandths, so I had somewhere between 1.5 and 2 thousandths of an inch of clearance. Common specs are around 1.5 to 3 thousandths of an inch for side clearance, and some use a little bit wider range of about 1 to 4 thousandths of an inch. Either way, I had enough clearance, and the ring did move more freely again once installed, so I cleaned both parts once more for good measure, just in case there was some sort of debris left over that initially caused it to feel tight. I used a micrometer and a dial bore gauge to take precise measurements of the piston and cylinder. Here are those measurements alongside my measurements of this kit before it was installed for comparison. The piston is worn 1.5 thousandths or 0.038 millimeters, and the cylinder has worn as much as 2 10,000ths or about 5 microns. Piston to cylinder clearance now ranges from 4.5 to almost 5 thousandths of an inch, or 0.114 to 0.124 millimeters. That's definitely more clearance than I'd like to have, but not something that concerns me at the moment. Out of the box, the clearance was significantly larger than Malosi's spec. I did go ahead and order a larger C-piston to use in the somewhat near future, but I don't see the need to replace the piston right now and don't suspect that the wear has anything to do with the high throttle or heavy load sputtering issues. I put the engine back together, checked squish clearance, and did a pressure test before tossing it back in the scoot and putting the VHS T-carb back on with a 145 main jet. When it was time to fill the cooling system, I used plain distilled water with no coolant or any other additives. I wanted to flush the system later to get rid of any dirt or debris, and I was too cheap to buy radiator flush additive or waste coolant. A storm was rolling in by the time I got everything together, but I did manage to get a quick 5 to 6 mile ride in before it started raining. To my surprise, it ran pretty clean when I tried a few wide open throttle tests. Not perfect, but not bad, and certainly a big improvement. I couldn't believe that it may actually be fixed, so I went for another ride the next morning to make sure it still ran well. It started out okay, but transitioned to breaking up as I held the throttle. Then it rapidly degraded and went right back to the way it was before engine disassembly. Having it work all right at wide open throttle right after fresh O-rings, and then quickly reverting back to breaking up, made me worry a bit that it could indeed be a sealing issue. I also thought that it could be an ignition component that fails once hot, but that didn't really make sense because it should be fine at the beginning of every ride and then get worse as it heats up, rather than being okay for a short time and then always breaking up after that. I definitely didn't want to pull the engine right back apart to explore sealing troubles just yet. First, I wanted to flush the cooling system, and then I'd try a few more tests. I drained the coolant, which was filled with distilled water only, and it came out sort of gray or brownish with a hint of green, with a bunch of small black particles that settled to the bottom. I refilled it again with plain water, ran the electric water pump for a minute, and then drained it again. This time it came out gray with particulate settling at the bottom. I repeated the process, and the water came out light gray and then clear, but it still had the black particles in it. I kept doing this, and I saw less and less black particles, and on the 10th fill and drain cycle, I didn't see any, so I did it one more time for good measure before refilling it with water so I could run the engine again. I tried a few more ignition tests next, beginning with swapping the CDI. I took a ride with a new CDI, and nothing changed. I drained the cooling system when I came back because I wanted to see if the water still came out clean, and it did. So I hoped that the particles were left over from past setups and not a sign of combustion byproducts entering the cooling system. Once the radiators were refilled, I removed the spark plug. I was going to work with this one, but it was covered in fuel and the porcelain was black and the end had a groove worn into it, so I got out a new plug. These iridium plugs are fragile, so I use feeler gauges and won't apply pressure when checking the gap. Measuring that way, the gap was 26 thousandths of an inch. The spec for the Denso IW34 is 0.7 millimeters, or just shy of 28 thousandths, so I gapped it to half of that spec at 14 thousandths of an inch. This is normally one of the first things that I try when I'm troubleshooting because it can show you if you have a weak ignition component, and it's a very quick check. If the engine runs fine with a small gap and poorly with a standard gap, most of the time it means something is not fully functional in the ignition system. While I was doing that, I decided to swap out the spark plug cap as well. It didn't feel really loose, but it wasn't snug either. I don't usually like to change more than one thing at a time, but in this case I went for it because honestly I was tired of troubleshooting and not optimistic at all about anything working. Oh, well, I guess it does help if the fuel is turned on. I won't say that wide open throttle felt perfect, but it wasn't breaking up bad anymore, and it felt a little bit stronger than it has overall. I rode about 5 miles to see if it started doing it again, but it ran fine the whole time. So either the new plug or the new cap or the small gap fixed it. I took the plug out and gapped it back up to 26 thousandths before taking another ride. It was still fine. I can say for sure that the new plug or the new cap fixed it, but I can't be 100% certain which one it was without putting each one of the old parts back on and retesting. I've had more than enough of sputtering engines lately, so that's just not happening. I think that most likely it was the cap or the combination of the cap and the worn plug end, but regardless, I would guess that if I had changed the plug cap when the plug fouled on the ride from my friend's house, I probably wouldn't have went through all of this. A roughly $4 part or a quick small spark plug gap test could have saved me a whole lot of trouble. Checking the spark strength with an adjustable tester is not a bad thing to try, but I shouldn't have taken the fact that it could jump a ½ inch or greater gap as assurance that everything was fine in the ignition system. The additional checks would have been much faster and easier than removing and inspecting the engine, but again, I'm not upset about doing an inspection around 500 miles because it gives us a little bit of info about how the engine wears, and it has allowed me to order a piston to have on hand so I can replace it before long. I hope that it continues to run well and I can start doing some tuning now. Subscribe so you don't miss that, and please give this video a like if you found it helpful or enjoyed it. Thank you for watching.